Good afternoon, AP Stat students. I thought I would try out a new screencasting software called Camtasia that lets me record my screen, and I thought I would use the beer simulation that we did in class a few weeks ago. So here we go. All right, what we have is we have a simulation set up to sample 20 students from Ohio State University, and we're going to look at the linear relationship between two quantitative variables: number of beers consumed and blood alcohol content 30 minutes after consuming the last beer. So to sample, we just select this button, Sample More Cases, and you'll notice that we'll get a graph of beers against BAC. We'll get a residual plot, and over here we actually have the data itself. So for instance, in this particular sample, the first person consumed 3 beers, and 30 minutes after consuming those 3 beers, their blood alcohol content was 0.05. All right, and we can do that as many times as we want. Every time we click it, we get a new set of data. And you'll notice that the samples all look very different. Okay, so let's take a look at this one. We're going to use Liner, if you remember. I'm going to try out this new drawing tool that they have in Camtasia. And so I have a little bamboo tablet. See if I can figure out where to write on the screen. So here we go. And so we have Liner as an acronym, and we'll talk about those things, or just review real quickly what these 3 things are. So L is does the data look relatively linear? And it looks sort of linear, not too bad. So we got the L out of the way. I is independence. Is it reasonable to assume that the outcomes, the BAC measurements, are independent from one another? We'll just have to assume that. N is, are the error terms normally distributed? It's kind of hard to tell when you look at a residual plot. You would expect the points to be really, really close to 0, most of the points, and then a few of them bearing out. Equal variances, to check that, we draw vertical lines above, below, and we hope that the points kind of vary in between these 2 lines equally. And R, did we take a random sample from some population? In this particular case, we have 20 volunteers, so that assumption is not really valid. So we wouldn't want to make inference about all Ohio State students unless we actually could take a random sample of those students. All right, I'm going to clean that up real quick. So one more time, if I click this button, we get a set of data, we graph it, we look at a residual plot, and over here we actually have the data that we can look at. So you can stop and pause and look at this, as much as you want, and just kind of mess around, see what it looks like. All right, we'll stay here with this one. So let's look down here. Down on the bottom here, we have the actual equation. So our estimate for the slope is let's actually get the drawing tool here, is 0.014. And our estimate of the y-intercept is 0.0013. If I take another sample, I would expect to get a different slope and a different y-intercept. So the thing we're interested in here is estimating, I'm trying to get my little drawing tool here, the true slope. So that's my parameter, and I'm going to use this, which is B. So we're going to use B to estimate the true slope. What this simulation will allow us to do is to see how B behaves and see how good an estimate and how much variability it has. All right, clean this up. I'm going to open this guy up right here. And this guy lets me grab other slope. So if you look down here, we have 0.012, and notice that we plotted 0.012 over here. And if I click this button off and I'll move this up here a little bit, and I click it again, we get another slope. This time we got 0.015, so we have 0.015 plotted and 0.012, and do it again. We get another one, another one, another one. I think we've done it 5 times. So let's do it a bunch of times. And click that button. This shouldn't take long. We should have 100 of them when we get done. So I'm interested in 2 things here. I'm interested in the shape of this sampling distribution. So it's a partial sampling distribution. We only have 100 samples, but oops, that is not the drawing tool. It looks relatively mound-shaped, and it's centered at 0.0148. Now let's throw a few more up there. Turn off the drawing tool, and we'll do 100 more. That's not 100. And you notice it gets more mound-shaped, and it's right now centered at about 0.014. Now if I scroll down below, I have the actual parameter set up, and when I set this up, I set the true slope to be 0.015, and so this guy right here, set my draw, and you'll notice that the 200 slopes that I collected are pretty close to 0.015, 0.0148. All right, that's all I have to say about the simulation today. I just want to kind of check this out. I hope you got something from it. All right, have a good rest of the day, whatever time of the day it is for you.